Good morning, Year 6. Welcome back to your maths lesson. Today is Thursday, the 25th of February. It's on to lesson 4 of ratio now. So I'll start sharing my screen so we can get straight into the lesson. Oh, not that one. There we go. So our learning objective today, as you can see, is to understand the term scale factor and its relationship with ratio and shape, okay? So we'll get into that soon, but firstly, your Fast 5 is on the board, or there's 6 today. So your 6 starter questions are on the board. Pause it here to have a go, and then I'll come back to you with the answers, okay? Okay, Year 6, well done. I hope that wasn't too tricky. Just a reminder on time. So your answers are up on the screen. So number 1, I left my house for work at 7:35 a.m. When I got home, the time was 4:27 p.m. How long was I out of the house for? Okay, and your answer is 8 hours and 52 minutes. Okay, 8 hours and 52 minutes. Okay, and the way we would have done this is to create our timelines. Okay, so I've got a little example timeline at the top here, and I've got my 7:35 a.m. and then I've got my 4:27 p.m. at the end, and I've put 8 a.m. in the middle here. Realistically, I would probably put my 8 a.m. around here, okay, because it's just next to 7 a.m., 7:35 a.m., obviously. So I would do my first little jump of 7:35 a.m. to 8 a.m. So that's a nice round number, okay, and that's 25 minutes. That's 25 minutes. And then what I'd do is I'd probably do a jump from 8 a.m. all the way to 4 p.m., okay? A jump all the way from 8 a.m. to 4 p.m. So that is 8 hours, okay? So I'd count up and that is 8 hours. Sorry, that's not too clear, but that's another jump, 8 hours to 4 p.m. to 4 p.m. Sorry, I should have made that clear. And then we do one last little jump to 4:27, okay? So I'll put the 4:27 there, okay? 4:27, which is another 27 minutes. And then all we need to do is just simply add them up. Okay, so we've got our 8 hours, and then we just add our 25 minutes and our 27 minutes, which gives us 52. So our answer is 8 hours and 52 minutes, okay? So well done if that was the answer that you got. Number 2 now. I got to my class at 11:13 a.m. I was 43 minutes late. What time did my class start? Okay, so once again, we just be counting backwards this time, and it is 10:30 a.m. Number 3, write the time 20 to 4 in the morning in a digital clock format, and this is it written here, okay? So 3:40 a.m., okay? I'd like to see you writing your AMs and your PMs, so don't want you to forget that. Number 4, how many hours are in 6 days? Okay, so we know that there are 24 hours in a day, and all we'd be doing is timesing that by 6, okay, which gives us the answer of 144. So 144 hours. Number 5, what is 499 minutes in hours and minutes? And our answer is 8 hours and 19 minutes. Once again, we know that 60 minutes are in 1 hour, so we would just divide our 499 by 60, and then we'd work out the remaining minutes, okay? So it's 8 hours and 90 minutes. And number 6, how many full days are in 320 hours, okay? So it's 13 days, and there are 8 hours spare, okay? So your answer is 13 days, and there were 8 hours spare, okay? So well done for completing that. I hope that was a nice little recap on time for you. But today we're going to be looking at scale factor. So let's have a look at our big question. Our big question today is up on screen. Quite a simple one, quite a basic one looking like. Draw a rectangle 3 centimeters by 4 centimeters. Enlarge your rectangle by scale factor 2. Compare the perimeter, area, and angles of your 2 rectangles. Okay, so if you'd like to have a pause and have a go, feel absolutely free to do that. And then I'll go through a little bit of input and then we'll come back to our big question. So what is scale factor? We use scale factor when we talk about increasing the size of a shape. Okay, so changing the size of a shape, a 2D shape to be specific. The size by which we make this shape larger is described by its scale factor. So for example, if I enlarged a shape by scale factor 2, I would be doubling the size of it. It would be 2 times as big, okay? And I think that's quite a key phrase when we're talking about scale factor, is it's the amount of times as big you're creating, okay? So if I enlarge the shape by scale factor 3, then it would be 3 times as big. I would be tripling the size, okay? So all it really is multiplying its size, okay? So just like I've said, yeah, much like if I enlarge the shape by scale factor 3, it would be 3 times the size, okay? So let's look at it back in context again of our big question, okay? So draw a rectangle 3 centimeters by 4 centimeters, okay? So I'll highlight that first of all. As I say, we always like to highlight the key information. So I've got my rectangle. I've got my 3 centimeters here on the side. So my 3 centimeters and then 4 down the bottom here, okay? That's my 4 centimeters. Enlarge your rectangle by scale factor 2, okay? And if you remember what we said, for example, if I enlarge the shape by scale factor 2, I would be doubling the size of it, okay? It would be 2 times as big, okay? So we've got to make our shape 2 times as big. And it's important that we recognize the measurements that we were given in the question, okay? So we've got draw a rectangle by 3 centimeters by 4 centimeters, okay? So we've been given measurements and numbers, and now we simply have to double it, okay? We have to enlarge it by scale factor 2, make it twice as big, okay? So I don't have that many squares on my sheet here. I'm going to try and just probably make this a little bit smaller, just so that I can get this on the screen, okay? So if I had my rectangle is 3 centimeters and I want to double it, it's going to make this side 6 centimeters, isn't it? It's going to not be 3 squares, it needs to be twice as big, so it needs to be 6 squares, okay? So I'm going to go from the bottom. I'll probably go from here, okay? I'm going to overlap it a little bit, so sorry. 1, 2, 3, 4, 5, 6. So it's all the way to the top, okay? It's all the way to the top. And then we've got 4 as the bottom, okay? So 1, 2, 3, 4. And as we read, we're enlarging it by scale factor 2. So this is going to be doubled, giving us 8, okay? So we need to count out 8 squares. 1, 2, 3, 4, 5, 6, 7, 8. So once again, this is filling out the page all the way to the end. And then all I would do is just finish off my rectangle now, okay? So once again, it's the same up on the other side, and then the same across the top, okay? So now I have my rectangle where this length is 8 centimeters and this length here is 6 centimeters, okay? So now I have enlarged my shape by a scale factor 2 because it is twice as big, okay? Our 3 has gone to 6 and our 4 has gone to 8. All right, so let's have a go here at our question here. Okay, so I have a triangle measuring 3 centimeters in width and 2 centimeters in height. I would like to enlarge my triangle by scale factor 3. Choose my correct answer. And it says draw the new shape to scale, but I'm going to cross that out because I don't have enough space to make it to scale. So as you can see, it's not drawn to scale. And what this means is that the measurements I've written are going to be different here, but they're not, the shapes aren't necessarily showing these measurements just because I can't fit it on, okay? So what I'd like you to do is just read the measurements down here, and on the sides, and then you can work out whether it has been enlarged by the right amount, okay? So you just need to look at the measurements here. If I could have drawn them out into the right sizes in the squares, then I would have, okay? So it's not drawn to scale. So I would like to enlarge my triangle by scale factor 3. Choose my correct answer. Okay, so pause the screen here and then have a go at this, and then I will come back to you and I'll tell you the right answer, okay? Okay, year 6, well done. I hope that wasn't too tricky. I hope you've had a guess. So I have a triangle measuring 3 centimeters in width and 2 centimeters in height. Oh, I also just realized none of these are triangles, sorry. Imagine this says rectangle, okay? I have a rectangle measuring 3 centimeters in width and 2 centimeters in height, okay? So we've looked at our information. We've got 3 centimeters and 2 centimeters. And then we read our question. I would like to enlarge my triangle by scale factor 3, okay? And as we know, this means it's got to be 3 times as big. We're tripling it. So we're going to look at our measurements again. 3 centimeters. If we do triple, 3 times as big as 3 centimeters, 3 times 3, it gives us 9 centimeters, okay? So that is what we think our measurement should be on the bottom. And then up the side, we've got 2 centimeters. And we'll do 2 times 3, because it's got to be scale factor 3, 3 times as big, which gives us 6 centimeters, okay? So now we know that we're looking for a rectangle with 9 centimeters along the bottom and 6 centimeters along the sides, okay? So we'll look around and C is our answer, okay? So C is the shape which has been enlarged by scale factor 3, okay? So continuing on to the next slide now. Okay, 6. So let's do a bit of me and we, okay? So enlarging these shapes, okay? So we've got a triangle and we've got a rectangle. Once again, I'm aware that it's going to be a little bit tricky with you being able to draw at home and being able to actually physically draw out these enlargements, okay? So I'll do the me and I'll show you how it's done. And then for the we, what we'll do is we'll hypothetically do it in a way. Oh, my bad. And what we'll do is you will just have to be able to tell me the measurements, okay, what the actual measurements would be rather than drawing the shape itself, okay? So enlarge these shapes by scale factor 2, okay? So the first shape we've got is a rectangle here, okay? And it's 5 centimeters along the bottom and 2 centimeters along the sides, okay? So we're enlarging it by scale factor 2, okay? So I'm going to highlight my important information there, and I've got 5 centimeters and 2 centimeters. So let's start along the side where we've got our 2. Enlarging by scale factor 2, we know it's going to be twice as big. So we're going to do double, okay? So 2 doubled is 4. So I'll go 1, 2, 3, and 4, okay? So I've gone 4 up. I'm actually going to put it a little bit higher up, okay? 4 here, okay? So now we've got our 5, and we're going to double that as well, giving us 10. So we'll go 10 squares along the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then we'll just simply finish off our rectangle. Okay, so this really isn't that tricky. Enlarging by scale factor 2, just doubling it. And then we've got our line along here as 10 centimeters. Remembering, pardon me, remembering to always label and use our units. Okay, and then we've got our length along here as 4 centimeters. Okay, so now we have successfully enlarged this rectangle by scale factor 2. Okay, by scale factor 2. So I'll rub this out. And then we will have a go at doing the triangle. Okay, we'll have a go at doing the triangle. So the triangle is 6 centimeters along the bottom and 2 centimeters up. So we could have just kept that 4 up here because we got the 2 along the side and we're enlarging by scale factor 2. And then we've got the 6, which is 12 along the bottom, okay, which is 12 along the bottom. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh no, I couldn't get 12. I'll tell you what I'll do is I'll move that along, move this along, and then I can finish it off 12, okay? And then as usual, I'll just finish off the triangle. And there we go. I've enlarged it by scale factor 2, okay? I've enlarged it by scale factor 2 because we've got our 12 centimeters along the bottom and our 4 centimeters along the side, and we don't know what this length is, and that's fine. So what I'd like you guys to have a go at is telling me what the lengths of the different sides would be of each of these shapes, of these 2 shapes, if I enlarge them by a scale factor 3 and if I enlarge them by a scale factor 4. Okay, so I'll give you a little bit of a hint for the first one. Scale factor 3, I'm going to be multiplying my numbers by 3 to get my answer, okay? So give the screen a pause, have a go at that, and then we will move on, okay? Okay, six, well done. So I've got the answers up on screen now. So for scale factor 3, I've got the square, the length along the bottom would be 15 centimeters because it's 3 times as big. Okay, we're tripling it. And then along the side is 6 centimeters because it's 2 times 3, okay? The triangle, 18 centimeters along the bottom and 6 centimeters up the side. And scale factor 4, we're simply timesing each number by 4, okay? So along the bottom of the square, it's 20 centimeters, along the side, 8 centimeters, triangle, 24 centimeters and 8 centimeters, okay? So well done if you got those answers. And now I've got your U up on the board, okay? So have a go at this question here, which says, Jack says, the purple triangle is the green triangle enlarged by scale factor 3. Do you agree? Explain why, okay? So give the screen a pause, have another read of the question, see what you think, and then I'll come back to you with the answer. Okay, six, so well done if you had a go at that question. And the answer, I would say, is no, I do not agree, because Jack has increased the green shape by adding 3 centimeters to each side, to each side, not increasing it by scale factor of 3. Okay, so let's have a look at our measurements. We've got 3 centimeters along the side and then 6 centimeters on the purple one. We've got 5 along the longest side and 8 on the purple one, and then 4 to 7. Okay, oh, let me move that a little bit so that you can actually see it. There we go. So if we look at our first one, 3 to 6, and we think about how would we get from 3 to 6, okay, we double it, okay? Double it, which is increasing by a scale factor of 2, which we immediately think Jack must be wrong because he said the purple triangle is the green triangle enlarged by a scale factor of 3. So straight away we know, but we'll double check anyway, okay? So we'll go to the next one, 4 centimeters to 7 centimeters on the purple one, okay? It's changed to 7 centimeters. Now this is being added by 3 to get to 7 because we can't double 4 to get to 7, can we? Because it gets to 8. So what Jack has clearly done is just added 3 centimeters to each instead of multiplying each one by 3, okay? Which is what we would have done because it's 3 times as big, okay? So well done if that's the answer that you've got. And let's just move straight on to our success criteria, okay? Okay, six, so your success criteria is up on screen now. So to highlight important information in the question. So for example, the measurements, okay? So I'm always stressing the importance of highlighting the key information in the question. And this does come in the form of the measurements, okay? So any measurements that you see, you underline them just so you're aware of them and you're not making any mistakes, okay? We have to identify the scale factor that it needs to be enlarged by. So this will be in the question as well. So that is something we'll underline. The scale factor that we're changing the shape by, that we're enlarging the shape by, and then multiply each length by that scale factor, okay? So, and this is remembering our how many times as big. So if it's scale factor 2, it's 2 times as big. Scale factor 3, 3 times as big, and so on and so forth, okay? So do not forget that it's simply just multiplying, okay? It's a fairly basic way of enlarging a shape, okay? So your assignment is up on Teams, so feel free to go and complete that, the quiz. If you can't access it, please email the Year 6 email and we'll send you those questions. And I look forward to seeing how well you do with this topic. Well done, Year 6.